Hello, we're going to continue our conversation on binomial distributions. Let's first think about what we talked about in the previous lesson and do a little bit of review. So let's say that selected boxes of cereal contain a prize. Suppose that 5% of the boxes of your favorite breakfast cereal contain a prize, and then the other 95% contain the message, sorry, try again. You go to the grocery store and you really want a prize, so you buy 25 boxes of your favorite breakfast cereal. So we're going to find the probability that exactly 2 boxes contain a prize. When we have this, so this is an example of a binomial distribution, okay? We have a fixed number of attempts, 25. We have 2 outcomes, either prize or no prize. The outcomes are going to be independent, we assume that. And then again, this probability is consistent, this 5%. So because we can use a binomial and we're using exactly 2, that means that exactly 2 means that we're going to use the binomial PDF. Our n, our number of attempts, is 25. Our probability of a success is this 5%. You guys, that's going to be 0.05. Remember, 0.5 would mean 50%. So 5% is 0.05. And exactly 2 means that we're going to have this 2 that's right here. Okay? We talked about putting those into the calculator. Again, PDF is because it's exact. It's just looking at exactly 2. If you put that in the calculator, that should be about 0.231. or 23.1%. Okay. Next, it asks to find the probability that 5 boxes or less contain a prize. So here we want 5 boxes or less. That means that we could have 5 or 4 or 3 all the way down to 0. And because we're summing several together from 0, this is where we're going to use the binomial CDF. The C is cumulative from 0. Our total is 25. Our probability is 0.05. And again, we're going to go cumulative from 0 all the way up to 5 because we do include 5 boxes or less. And if we do enter that in, again, just to kind of remind you, we're going to do second vars. We go to binom CDF, and then we have 25 trials, a P of 0.05, and the X value is 5. And we see here that that 7 bumps that 8 up to a 9. So this is very close to happening all the time. So 0.999 or 99.9% of the time. Okay. Then it says, how many prizes do you expect to find in these 25 boxes? And remember that when we talk about expected value, is that expected value is just n times p. My n was 25. My p was 0.05. And so I could multiply those together and I get 1.25 prizes. I understand that we can't have a fraction of a prize, but this is like a mean. The expected value is like the average prizes that you would expect to have. So we do include the decimal for that. Okay, so we would say that our expected value would be 1.25 prizes. So let's continue our conversation. The binomial CDF function in the calculator can only add up probabilities of an event at a specific value and lower. For these next questions, we're going to use the concept of complementary events and subtract what we don't want from 1. So here this one says, find the probability that, that 5 or more boxes contain a prize. And I want us just to think really quick about the possibility of prizes here, okay? The lowest number of prizes that are possible are 0, and the highest possible is 25, okay? So that box represents all of the prizes that are possible. So this is 100% of the possibilities. We could have 0 prizes all the way up through 25. Okay. Now this is talking about 5 or more boxes containing a prize. Okay. So I want 5 or more to contain a prize. Okay. So this would represent the 5 or more. And so what that means is that if this is the 5 or more, the other part then would be 0 all the way to 4. This is the part that we want, right? We want to find the 5 or more. But the calculator only sums from 0. So what that means is that this is what we could find in the calculator, right? We could find the cumulative probability of 0 through 4. And then to get this part, what we would do is we would take the 100% and subtract that part off. And so essentially what's going to happen is, since this whole thing is 100%, what we're going to do to find this part is we're going to take 1 minus the binomial CDF of 0 through 4. So we have 25.05 and 4. Okay, so this is what we want. This is what the calculator gives us. And this whole thing is equivalent to 1 whole, right? 100% is 1 whole, essentially, right? So what we can do is take the 1 whole minus what the calculator gives us, and then that's what we want, okay? And so that's what this represents here, 1 minus the binomial CDF of 25.054. We can just put that in the calculator right as is. 1 minus second vars, and then we do binomial CDF, and then we have 25, the 0.05, and then this time we're subtracting off 4. Okay, and that gives me about 0.007. I would like you to notice that even though the question says 5, this number was not 5. I wanted 5 or more, so I had to subtract off 4 or less. Okay? There are just too many times that people will automatically put this number in for K, and we can't do that. We really have to think about that. I encourage you to kind of draw some sort of picture like this, and we'll do it together several times so that you get a little more used to it. Okay. And then again, I'll happy cloud the whole answer. Really, it's just the 0.007 or the 0.7% that is our answer, but please write this down so that we know how you got that. Okay. So then the next question says, find the probability that more than 3 boxes contain a prize. Well, let's think about the boxes again. We can have from 0 to 25, okay? We want more than 3 to contain a prize. So how many would be more than 3? More than 3 would be 4 or 5, all the way up to 25. So this represents the more than 3. Okay. So more than 3 is 4 or more. So what's on the other side of that? That would mean I would want everything from 0 to 3. Again, this right here is what we want. This is what the calculator can give me. So I'm going to take this 1 whole, and I'm going to subtract off 3 or less using the binomial CDF of 25.053. And if I subtract off 3 or less, it gives me more than 3. Okay, so again, you also can't use the rule like, oh, I always add or subtract 1. Look, now here they're the same. So we really have to think about what that means. And when we put that in the calculator, we should end up getting 0.034 or 3.4%. Okay. So that's the new thing for today. The new thing for today is the idea that if we want something that's more than K, we take 1 minus the binomial CDF. Okay. So if we want what's on the right, we take 1 whole, subtract off the left, and that gives us what we wanted. Okay? So that's really the only thing that we're adding to this today. So let's look at a full example. It says you're taking a multiple choice test consisting of 50 questions with 5 choices for each question. Suppose you haven't studied, so you must guess for every question. It says find the probability of getting exactly 15 questions correct. Well, I can tell that our N is going to be 50, but what is our P? What's our probability? Well, let's think about it. There are 5 choices and only one of those is right. So our P is going to be 1 out of 5, which is 0.2. So here they didn't say 20% you're going to get right. Here you have to kind of infer that from the question. So you have 5 options, only one of the 5 is correct. So that means you have a 20% chance for each question getting that correct. So this first one is saying find the probability of getting exactly 15 questions correct. So again, exactly 15 means that I can just use binomial PDF, okay? And we have 50 questions total. My P, my probability is 0.2, and exactly 15 means I'm going to want the exact value for 15 that's here, okay? So if I then try to enter that into the calculator, so I go to second vars, down to binomial PDF, and I have 50 trials, a probability of 20%, which is 0.2, and an X value of 15. Again, let's talk about what this is. It's 0.0299. This 9 tells me to bump this 29 up to a 30. So this is going to be about 0.030, which is about 3.0%. And again, I would keep the 0.0%. That tells you how close it is to 3%, that it's not 3.4%, it's not 2.95%, it's that close to 3.0%. Okay, so that's example 1A. Now in example 1B, it says to find the probability of getting a 50% or lower on the test. So a 50% or lower essentially means that a 50% would be half of them, which would be 25 or less, okay? And when we think about that, here we have 50 questions. If you were to draw a little box for this one, you could have 0 to 50. And so essentially here we would want the 0 through 25. But this is what the calculator gives us, and this is what we want. So because this is what the calculator gives us and it's what we want, we just have to use the binomial cumulative distribution to get all of these values from 0 to 25. So again, we're going to have 50.2, and then we're going to go all the way to 25 because we want a 50% or lower. And let's take a look at what this indicates. Oops, sorry. So if we do second vars and then we go down to binomial CDF and we have 50.2 and 25. In this case, we have this 0.999. So that rounds that up to 1,000, which if we round to 3 decimal places, is going to be 1.00. That's why it's important for us to say approximately 1.000, that it's about 100.0%, okay? This means because of the approximate, it doesn't mean that it's for sure going to happen, but it means it's probably going to happen, all right? So that's why the approximately is very important. When we round appropriately, it does round to almost 1, which means that we're almost certain that we would get a 50% or lower. But we have the approximate because there is a chance that that's not going to happen. Okay? So then letter C says to find the probability of getting at least 10 questions correct on the test. So at least 10 questions correct. So let's think about what this would look like here. We have values from 0 all the way to 50, and we want at least 10 questions correct. Okay? So this is what we want. This is the at least 10. Okay, this is what we want. But the calculator doesn't tell us that. The calculator only tells us this here. Well, if we want 10 or more, that means that the other side would have everything from 0 through 9. And so what we want is we're going to take this whole, this one whole, and we're going to subtract this part off. We're going to take off the binomial cumulative of 50 trials, 20% success, all the way up through 9. Okay. So again, because this is what we want, we can take 100%, which is this whole, subtract off the binomial CDF that tells us everything from 0 through 9, and that'll give us our result. So if we take 1 minus second bars, and again, the binomial CDF of 50.2 and 9. Again, make sure you have the 1 minus. That gives us about 0.556. Or 55.6%. Okay, so those are really the 3 different types that you could have. Exactly, where we use PDF. Something where it's cumulative from 0, so things that are less than something, where we use CDF. And then when it's more than something, we take 1 minus that binomial CDF. Okay. And then here this says, how many questions do you expect to get correct? And remember, when we see this expect, that this is like our expected value. Okay. Our expected value is n times p. Our n was 50 questions. Our p was 0.2. So we're expected to guess and maybe get it correct 20% of the time. And 50 times 0.2 gives me 10. So that means that I would expect to only get 10 questions correct if I were to guess. So not a good one. All right. Okay. So now here's an opportunity just to practice a little bit. So this says that during the 2008-2009 playoffs, Sidney Crosby made 19% of his shots on goal, which was 15 of 79, which was much higher than his regular season rate of 13.9%. Does his better than expected playoff performance provide convincing evidence that he's a clutch player? Well, we looked at some of this idea of being a clutch player in earlier chapters using hypothesis tests. But what we can do now is use this binomial distribution to make a decision as far as if something is very likely to happen or not. So let's assume that Crosby's ability to score a goal is 13.9%. So I know that there are 2 percentages here, you guys, but this is what we're going to use as our p-value. We're going to use that p is 0.13. Okay. And we're looking at his playoffs, and it looks like he had 15 out of 79 shots. So this 79 shots is going to be our attempts. So that's going to be our N. And what I'd like you to do is letters A, B, and C. Okay, so use this information and think about what we're going to do for exactly 12, for less than 10, and what we would do for 15 or more. Okay, so see if you can use the examples that we have done on the front to help you with that. All right, so don't cheat. Pause. I'm going to pause the video while you work on those questions and see how you do. Okay, let's see how you did. In letter A, I got 0.118 or 11.8%. Exactly 12 means we're going to use PDF. And the K value that we use is 12 because it's exactly 12. Okay. And again, in all of these cases in this your turn, the N is 79 and then the P is 0.139. All right. In letter B, I got 0.326 or 32.6%. Less than 10 does not include 10. Less than 10 is going to be everything 0 through 9. That's what I want. So I'm going to use the cumulative all the way up through 9. 0 through 9 is less than 10. Okay. Then in letter C, it says if this one is how likely it is to make 15 or more shots. So 15 or more is what I would want. And that means that I would need to subtract off 14 or less. So I would subtract off 0 through 14 of the, sorry, I don't know why that screen is on here. Okay, I'd subtract off 0 through 14 of the this here from the 1, and that gives me the 0.128 or the 12.8%. Okay. Now, based on the probability, so that's, stuff that we've talked about. So now based on the probability that we calculated in part C, is there convincing evidence that Crosby was a clutch player? Well, remember that what we had talked about a while ago was that things are unusual if it happens less than 5% of the time. Okay. Oops, sorry. So we've said that things are unusual if something happens less than 5% of the time. Well, let's look at what it said in letter C, because that's what we were looking at. The 15 or more shots is what actually happened. And so notice that letter C says that 15 or more has a 12.8% chance of happening. So is that unusual? It doesn't look like it, does it? Because this could happen 12.8% of the time. That doesn't seem very special. And so what we would answer here is no, because it's likely to happen by random chance. That's what our binomial distribution is telling us. More than 5% of the time. So because that value is more than 5%, that means that it's really not that special. Now, if it was something, like 0.0128 or something like that, that would be special because it would be less than 5%. But because this value that we found here is greater than 5%, it's really not that special, right? Now letter E, here's one more that you guys can do. It says, assuming Crosby's ability is 13.9%, how many shots would you expect him to make out of 79? Well, again, the expected value, we just take N times P. So that's 79 times 0.139. And if I take 79 times 0.139, that gives me 10.981 made shots. And again, I'm not going to round that to 11. I'm just going to keep that at 10.981 made shots because it's a statistic, and that statistic can have a decimal attached to it because it's an average. Okay? So my main concern here is like when you are going to use the CDF and the 1 minus the CDF. I think the PDF is pretty obvious because that's always exactly. But when you use the CDF, the 1 minus the CDF, and what that K value is, I can't tell you how many times people do not pay attention to what the K value is, and then they get incorrect answers, okay? So based on what we've talked about, it is kind of important to rethink each problem, to think about what it is that K or less that we're talking about. I don't need us to rewrite each of the statements to include K or less, but I am going to make a little picture to kind of help us decide what we should maybe use in these different functions, okay? So here, if I have 15 or less, okay, then that means I want, so we have some arbitrary number up here. It doesn't tell us our total. But what we have is we want everything from 0 all the way up to 15. And so what that means is that we would use the CDF with basically that last K value of 15, because I would want everything from 0 to 15. Okay? Let's say that I want less than 28. Okay? Here's my total. I want things less than 28. So I don't want to include 28. Less than 28 is everything 0 to 27. So what I would do is I would use CDF with K equals 27 in that last spot. Okay. What about at most 12? So at most 12 means that 12 is the highest that I could have. So I am going to include everything from 0 through 12. So I would use CDF with K equals 12. Okay. What if I wanted more than 22? Okay. Well, more than 22 means that I would want 23 or more. Okay. So this is what I want. More than 22 means I want 23 or more, which means I have to subtract this part off. So I would take 1 minus the CDF with K equals 22. Okay. Now what about 30 or more? So 30 or more means that I do want 30 and anything above. This is what I want, which means I need to subtract off this part. Well, that means that on this side, I'd be subtracting off 0 to 29. So I'm going to take 1 minus the CDF with K equals 29. Okay. Finally, I have at least 18. Okay. At least 18 means I do want to include 18 and up. So this is what I want. I want at least 18, which means I have to subtract this part off. So that's going to be subtracting off 0 to 17. So I want 1 minus the CDF, but my K is going to be 17. I just want to point out that like sometimes these numbers are the same. So notice like here, the numbers are the same, right? Here the numbers are the same. But there are times when they are not the same. So notice that there are specific times, for example, where we have a 28 here and a 27 here, a 30 here and a 29 here, an 18 here and a 17 here. So notice that they're not always the same. We have to do that thinking, you guys, okay? I urge you to kind of draw these stupid little boxes if it helps you to kind of make those decisions, okay? And that is a little bit about the binomial theorem. I hope you guys have an awesome day. Thanks.